Hey everyone, did you know that the touchscreen on your phone actually works because of capacitance? It's all about storing electric charge. Pretty cool, right? Let's dive into the world of electrostatic potential and capacitance. So, what exactly are electrostatic potential and capacitance? Simply put, potential is the work needed to move a charge, and capacitance is the ability to store charge. These concepts are super important for JEE, and you can expect to see direct questions on them. Let's learn how to tackle them. First, let's talk about electrostatic potential. Think of it as the work you need to do to bring a charge from infinitely far away to a specific point. It's a scalar quantity, meaning it only has magnitude, not direction. Remember, the potential is positive for positive charges and negative for negative charges. Okay, here's a key definition. Electric potential is the work done per unit charge to bring a positive test charge from infinity to a point. It's a scalar quantity. Got it? This means it's just a number, not a direction. Now, let's move on to the potential due to a point charge. A single point charge creates an electric field around it, and that creates a potential. The farther you move away from the charge, the lower the potential gets. Think of it like a hill. The closer you are to the top, the higher your potential energy. Alright, let's get to a super important formula. V equals kq over R. V is the electric potential, K is Coulomb's constant, Q is the charge, and R is the distance. Remember this formula. You'll use it a lot when calculating the potential from a single charge. Next up, electric potential energy. This is the energy that charges have because of their interactions. It's related to the amount of work you need to do to bring those charges together. The zero potential energy reference point is at infinity. This is a common assumption to simplify our calculations. Here's another crucial formula. U equals kq1 q2 over R. U is the potential energy, K is Coulomb's constant, Q1 and Q2 are the charges, and R is the distance between them. Make sure you use consistent units, like SI units, for accurate calculations. Here's a key point to remember. Potential is a scalar quantity, so you add potentials algebraically, meaning you need to consider the signs. Also, always remember that we usually take the zero potential reference to be at infinity. Examiners love to test you on sign conventions, so be careful. Let's try a quick JEE problem. Question. Two charges, 2 microcoulombs and minus 2 microcoulombs, are placed 6 centimeters apart. What's the potential at the midpoint? Solution. Since the potential from each charge will cancel each other out at the midpoint, the answer is 0 volts. Now, let's see how this applies in the real world. Capacitors, which are used in almost every electronic device, store electrical energy. They rely on these principles of electrostatic potential and capacitance to work. They are key for filtering signals and storing energy for quick release, like in a camera flash. Here are a few exam tips for you. Firstly, always pay close attention to the signs of the charges. Secondly, understand the relationship between the electric field and potential, E equals minus dV over drive. And thirdly, practice calculating potential energy as much as you can. Let's do a quick summary. Electrostatic potential is the work done per unit charge. The potential due to a point charge is V equals kq over R. And electric potential energy is the energy stored when charges interact. All of this, AI notes, doubt solving, practice tests for electrostatic potential and capacitance, is free on Synapse. Study smarter, not harder. Start free today at synapse.omups.in. Master electrostatic potential and capacitance for JEE. Please subscribe to our channel for more free lessons. Visit synapse.omups.in and start learning today.